Bonjour and good morning. Welcome to WASA Distance Education Center and PLAR Science. So we're into week 8 of term 1B. So that means after this week, we only have one more week left, which is week 9. And then the following week, the 27th through the 31st, reminder to students, that is admin week. That means there are no classes during that week, so if you're finishing up your key questions or your culminating activity, that's the time to get everything completed. So all students are welcome to join the radio Zoom classes. You can also contact your local DEC, or if you're not a student yet and you might want to sign up for the PLAR program, then you can contact Mary. Other PLAR students who are not signed up for this year, you can just do an application to get you back into the school year's timetable. And also students who are needing senior credits or other courses that you might want to sign up, you can contact Michelle. So we still have the independent learning courses. You can sign up anytime during the school year. You have to complete it though by on or before, June 13th, 2025. So if you have any questions about signing up, make sure you contact either your local DEC or one of our education counselors here at WASA. So we are continuing to hold 2 student draws. So you have one for students who earn a credit, and then one for those who submit work. So make sure that you submit your work to your teacher to be entered into the draw. Students working on multiple courses, so for example, if you're working on your PLAR Science, PLAR Math, PLAR History, or what have you, you will have your names entered for each of those subjects in which you submit work or earn a credit. Make sure that you are contacting your teacher. For myself, you can contact the office. We have a toll-free number. There's a fax number, my email. You can reach out to me on Facebook through Messenger under J. Mercer WASA. My office hour schedule is available from your DEC, or you can contact me to find out. And you can also call me at home, or again, use the Messenger feature, and I will get back to you as soon as I can. There are several options for you to submit your key questions or your culminating. You can have your DEC fax the culminating or key questions, or you can scan email to studentwork@nnec.on.ca. So make sure that you CC the teacher that's marking your work. So if it's PLAR History, Geography, and Science, you CC me. If it's PLAR Math and English, make sure that you CC Bonnie in the email. You can also use your Notes app to scan email. Another popular option is sending a picture through Messenger, or you can also drop it off at our WASA office. We do have an outdoor mailbox which is on the side entrance, or you can knock on the door and we will take your key questions or culminating from you. Just make sure that you write your name on your work. Students who are unable to attend classes or participate on Radio Zoom, you can watch our classes on YouTube. So you simply go to WASA Distance Education Center. So you go to YouTube, you search WASA Distance Education Center. This is what it looks like. Instead of clicking the home button, click on the playlist button. So if you click the playlist, then it will give you each subject. So you have PLAR Science, PLAR Math, NBV, which is the World Views and Aspirations of First Nations. You can see that the PLAR History, that was in Term 1A, all the classes are there. Same thing for the OLC 4.0, so if you're registered for the Ontario Literacy course and you need the literacy in order to graduate, make sure that you can access these videos. Click the subscribe button so that any new videos that are uploaded, you will get a notification. If you are unable to access it through YouTube, so if you don't have Wi-Fi or internet, you can request a USB of classes. So we don't send this out automatically. You have to ask for one, and we download the classes on a flash drive. So once you get the flash drive, you have to put it in a USB port, and then you can click open the lesson and you can listen or view the classes. So make sure when you're opening the class, just so that you are opening the right class, it's organized by subject, so in this case PLAR Science, then by lesson, then by key questions. So look at the key question that you might be having problems with, and then open that particular class. So NNEC students or WASA students, you have available to you NNEC Schools email. So if you want to have an nnecschools.org email, so separated from your personal email, you can ask for one. If you already have one and you're having problems getting in there, let one of us know. Sometimes it's just that you forgot your password. We can reset that. But if you're still having problems getting in there, we are able to activate your email or reset it if you like. For PLAR students, you have to let us know which option works best for you. We have been getting requests to find out if their lessons are coming in or when they can expect their lessons to come in. Let us know if you want to do the culminating instead of doing the lessons. So if you know for sure you want to do the lessons, then we will send you all 5 lessons. So for PLAR Science, it has 5 lessons and key questions. So you will do the key questions. There are 80 key questions. And if you have started this already, you can continue where you left off. So let's say you got as far as lesson 3 key questions, and then you reapplied this year. You can continue where you left off in lesson 3. If, however, you decide you have as far as lesson 3 completed and then you want to do the culminating, that's fine too. Okay, that's new this year, that you have options. Okay, you can choose whether you do the key questions or the culminating. Before, you had to do the key questions in order to do the culminating. Okay, not anymore. You can choose. So if you take option 2, which is just to take the culminating activity, then you can do this even if you have already finished a lesson. The culminating can be emailed to the DEC or to you, and you don't have to have supervision. That means you can take it home to complete. Successful students, these are students who receive 50% and above. So that means that's the passing mark. So once you complete all the PLAR subjects that you need to do, and you did it through the culminating, then you will receive your equivalent credits, and then you can proceed to doing the senior PLAR and then register for senior credits. If the culminating activity is not passed, that means if you don't get 50% and above, then you are to do the key questions in the lessons. So let's say in PLAR Science, you almost passed the culminating, but you didn't do well in chemistry or physics. So I will get you to do those key questions, okay, from the lesson. Students are permitted several attempts to pass the culminating activity. So if you try it once and you're not successful, okay, don't be discouraged. You can try it again. Okay, by doing the culminating, it actually lets you know which areas you may need to review. If you're still not sure, you can ask for a sample test to review the format of the culminating activity. So you just ask for, if you want the history, geography, or science, I have sample tests for that. If you want the math or the English, Bonnie will have the sample test for those subjects. So it looks like we may be completing lesson 4. We're almost completing lesson 4 today. I think we would be able to this morning. Let's see how far we get. From our last class, we got as far as, I think we did the electrostatic series. So we will continue with conductors and insulators on page 7. Lightning and lightning safety rules on page 8. What is electric current on page 9. Then some common electrical symbols and dry cells on page 10. And then current, electricity, amperes, volts, and ohms on page 12. So keep in mind the learning goals. I can explain the laws of electrostatics, and I can describe the similarities. That means what's the same, and then differences, what's different between current and static electricity. And then from our last class, we did for the key questions. So if you're doing the key questions, we did key questions 64, 65, and 66. And then we also did 68. Okay, so we still have 67, 69, 70 to 71 to complete. Like I said, we're almost done this lesson. It's a very short lesson. Okay, quick review. So electrostatics, we also know it as static electricity. That just means static electricity is electrical charges or electrons at rest. And we said there are 3 different types of charged objects. And you can follow along. Okay, we're reviewing this. So 3 different types of charged objects. We did neutral, and that means if it's neutral, just write it here. Neutral means you have an equal number of protons and electrons. So remember, protons are positive and electrons are negative. So that's neutral. Also, an object is positive if it has more protons than electrons. So we'll write, let me just erase that. Instead of positive, I'll write protons. Okay, so an object is positive if you have more protons than electrons. So let's say you have 8 protons and 5 electrons. So 8 is more than 5. So that means protons rule. So you have that object being positive. Then finally, so the opposite, an object is negative if they have more electrons. So remember, electrons are negative, and then you have protons are positive. So in this case, you have more electrons than protons, so that object is negative. So those are the 3 different types of charges. And then we looked at the law of static charges, or law of electrostatics. We said that unlike charges attract, basically if it's opposite charges. So if you have a positive and a negative, or a positive and a neutral, or vice versa, then those objects will attract. Like charges repel. So here's an example on the bottom of the screen. Both objects are negative. They will repel. Both objects are positive. They will repel. Neutrally charged objects are attracted to charged objects. So here's one. This object is positive. It will be attracted to a neutrally charged object, and vice versa. So this object is negative. It will be attracted to a neutral object. So as long as they're opposites, they will attract. If they're the same, they will repel. So that's something to keep in mind. Then we looked at the electrostatic series. This is basically a list that was created by scientists, and it shows what kind of charge different materials get when they are rubbed together. So when two materials are charged by friction or rubbing, the material higher on the list, which is the worst insulator, which is at the top of the series, they lose electrons and becomes positively charged. The ones on the bottom, or the material lower on the list, they are the best insulator. So they're at the bottom. They gain those electrons. Remember, the electrons are important. They're the ones that move, and they become negatively charged. So if you look at human skin, okay, that's right at the top. That's a weaker tendency to gain electrons. And as you move down to wool, cat fur, silk, paper, cotton, wood, amber, rubber balloon, vinyl, polyester, and ebonite, these are stronger, it has a stronger tendency to gain the electrons. And we did key questions 64 to 66. So I'll just go over. So we did 64, what did the ancient Greeks observe when amber was rubbed with wool? And then key question 65, what are the 3 laws of electrostatics? Key question 66, this one we did in class. You had to tell me the type of charge on each of the following objects, and then you explain your reasoning. So we looked at object A, and we noticed that object A has more electrons than protons, so we know that that object is negatively charged. Object B, we said, was neutral because it had the same number of protons and electrons. And then C, we said, was positively charged because it had more protons than electrons. And we also did key question 68, where you had to tell me whether there is attraction, repulsion, or neither. And A, we had a balloon which was negative to another balloon which was negative. We said the 2 balloons would repel, and the reason would be because like charges repel. And then B, an ebonite rod, which is negative, and you place it beside a glass rod, which is positive. So in this case, the 2 objects will attract, and the reason is unlike charges attract. So you have a positive and a negative. Opposite charges attract. Next up is if you turn to page page 8. So on page 8, we have right on the top of that page says conductors. So conductors, like metals, these are materials that allow electric charges to flow easily. And the reason for that is because metals have loosely held electrons, meaning the electrons in their atoms can move freely from one atom to another. So These free-moving electrons, they are not fixed. Okay, they're not static in one spot. They quickly spread out through the entire object when a charge is added. As a result, electric charges doesn't build up or stay on the surface of metals. Instead, they move throughout the material evenly. So we have some examples: copper, aluminum, steel, okay, any metal. These are materials that allows electric current to pass through it. These are called conductors. On the opposite side are insulators. Now, insulators, they are non-metals. These are materials that do not allow electric charges to move easily. In this case, the electrons in insulators are tightly bound to their atoms, so they can't move freely. The electrons in insulators stay in place around their individual atoms. So when an electric charge is added to an insulator, it stays in one spot rather than spreading throughout the material. That's why plastic or rubber are often used to cover wires, so that they can protect us from electric shocks. So some examples of insulators: we said plastic, rubber, okay, glass is another insulator, cloth, or wood. So anything that an object that prevents the passage of heat, cold, or electricity is what we know as an insulator. You can check out support question number 1 in your book. It says, identify the 3 subatomic particles that make up an atom. What are the charges of each of these particles? So you can do these for practice. The answers are at the end of the lesson. Number 2, in the examples given below, tell whether there is attraction, repulsion, or neither. And then number 3, a balloon rubbed with a flannel cloth will stick to the cloth, and it goes down to A, B, and C. So it says, do the balloon and the cloth have static electricity? If so, do they have like charges or opposite charges? Write your answer below. So if you see A before rubbing, so both objects are neutral. So the balloon is neutral and the cloth is neutral. And then after it's rubbed to the cloth, okay, the cloth loses some of the electrons. So now the balloon is negatively charged. And you can count the pluses and the minuses, so you can tell the balloon has more minuses than pluses. And then the cloth, you will notice that it has more pluses than minuses. So now you have positive and the balloon is negative. So that means they are attracted to each other. Okay, they will attract. Okay, our next topic is understanding lightning. Okay, we don't have to worry about that this month. So lightning is both dangerous and amazing to watch. In Canada, lightning causes an average of 9 to 10 deaths, between 100 and also 150 injuries each year. The majority of these incidents happen during the summer months. Like I said, we won't have to worry about it right now, particularly in June, July, and August, when thunderstorms are more frequent. Men aged 18 to 54 are the most common victims, often while engaging in outdoor recreational activities, so like fishing, golfing, so on. Ontario, Quebec, Alberta, and Saskatchewan, they account for the majority of lightning-related fatalities and injuries in the country. Okay, so what is lightning? Well, lightning is a giant spark of electricity that happens when electric charges jump between clouds or form a cloud to the ground, or from a cloud to the ground. So we're looking at this because it's still about static electricity. That's what it's caused by. So there's a buildup inside the clouds during a storm, and since electricity always looks for the shortest and easiest path to travel, lightning often strikes tall objects like trees or buildings. So you might have heard this before. If we're having an electrical storm, do not stand near tall objects like trees, buildings. To protect houses, many buildings have metal lightning rods that are placed on the roof. So when lightning hits the rod, the electricity flows safely through the rod into the ground, and this keeps people safe and prevents the house from being damaged. Here's some statistics on where most lightning deaths occur. 54% open fields, ballparks, golf courses, 23% under trees, 12% beach and boats, 7% operating farm equipment, and 4% near open windows or bicycling and so on. So again, talking about static electricity. So lightning is made in a similar way. The electricity moves from the negative towards the positive. So some parts of clouds end up with a lot of negative charges. So if you're looking at the picture that I have here, you have the cat's fur, and you have a balloon, okay, that's stuck on the cat's fur. So the earth can have positive charges, like the cat's fur. So if the difference between the two is big enough, the negative charge will be attracted to the positive charge. So a spark will jump between the cloud and the earth because opposites attract. The friction of water droplets and ice pellets colliding inside storm clouds causes lightning. So there you have it. There's a picture. If you look at the numbers, it says 1, ice and water particles separate. 2, negative charges fall to earth. 3, positive electricity rises from the ground. So you get the positive and negative, the two join and hit the ground. So you have the positive and negative, they're attracted to each other. So now you have a spark. So when the difference in charge between the positive ground and negative cloud is great enough, there is a discharge of electrons. So the result is the familiar cloud-to-ground lightning, also known as a forked lightning. So that's what it looks like. So what makes it so dangerous? Well, cloud-to-ground lightning can strike anything in its path as it takes the shortest route to the ground. The effects of lightning can be felt after the shock occurs. So trees that have been struck can catch fire. Power surges can damage appliances in homes and businesses. And if a lightning strikes a person, it can result in severe burns and even cardiac arrest. So there's the lightning rod that I mentioned earlier. So a lightning rod is a conductor. It's installed at the top of a tower or a tall building. Again, its intention is to attract lightning away from sensitive equipment, and it will divert the strike directly to the ground. So if you look at the picture on the bottom of the screen, you have two houses, one with a lightning rod, the one on the right. The one on the left does not have a lightning rod. So the lightning rod sticks up higher than the roof. So if a lightning strikes the rod, the electricity will travel through the metal rod all the way into the ground. So you can see on the left-hand side, it hit the TV or the television. So it damaged that particular appliance. But on the right-hand side, the rod diverted it to the ground. So you can check out in your book, there are lightning safety rules. So there's some here for inside and outside. If you're outside, don't stand under tall objects, like I said. Do not carry an umbrella. Many umbrellas have, or most umbrellas have that metal stem there, so it is a conductor. Don't fly a kite, avoid open areas, find shelters in building, okay, not canopies. Don't swim, okay, water is a conductor. Avoid using machinery. If you're inside, stay away from windows. Avoid electronic equipment. Don't wash dishes, unplug appliances, okay, do not bath, and so on. So I also gave you the link on page 9 for Environment Canada. You can check this out yourself. There are questions there that, FAQ, so frequently asked questions. For example, how many people are killed or injured by lightning in Canada each year? Where is the safest place to be during a thunderstorm? Can I use my cell phone or headset during a thunderstorm if I'm inside a house or a car? Will rubber boots protect me if I'm outside during a thunderstorm? So those are some questions that's there, and it will provide you with answers. Okay, let's try key question 69. Now, key question 69, you have to read a paragraph, and it's about Benjamin Franklin. He was a famous American. What he discovered was that lightning is a spark of electricity, and once during a thunderstorm, he flew a kite with a wire attached to it. Okay, he didn't just fly a kite, but he had a wire attached to it. And what he noticed was that metal wire attracted lightning. So here is the info. It says, one stormy night in 1752, Franklin carried out his famous kite experiment to prove that lightning is a form of electricity. So his equipment, he used a silk kite with a metal wire at the tip and a metal key attached to the string. When the kite was in a thundercloud, Franklin noticed parts of the string standing up like hair does due to static electricity. Franklin touched the key and there was a spark. It was an extremely dangerous thing to do, and he was lucky to survive. So the first question says, why should you not do this? And then the second part is, what can a kite act as? And I'll give you a hint there. Okay, we talked about insulators and conductors. So that's for key question 69. Okay, next we have, what is electric current? So think about how often you use electricity every day. Okay, you wake up to an alarm, you use your cell phone, or turn on the lights. So remember, your cell phone still has to be charged, so you're using electricity. You may use an electric toothbrush, or maybe you had to make breakfast, so you put bread in the toaster. You might also watch TV, use a tablet, or turn on the heat or furnace. Even just lights. So almost everywhere you go, there are electric lights. Now, if you could imagine life without electricity, that was about 100 years ago. Homes, schools, factories, and offices didn't have any electricity. So you can imagine how different that was. Here's a little activity that you can do on your own. This is how much do you rely on electricity. So you just simply do 3 columns, and the first column you would write the activity that you did, what equipment did you use, and whether you used electricity or not. So for example, the example here is read a book. The equipment used is a light bulb or lamp. And was electricity used? Yes. Played video games, equipment used, TV gaming system. So of course, yes. Okay, maybe you did an activity, cooking. If you used, maybe you used the stove. Equipment used, yes. Or electricity used is yes. What else? Maybe you watched your favorite show. So watch TV, and you use your television. So yes. Or maybe you played guitar, but you were using an electric guitar. So you use your guitar and your amp. So yes, you used electricity. So those are just different examples of checking how much do you rely on electricity. So on page 9, what is electric current? The electricity that powers your devices is called electric current. And again, this is the flow or use of flow of electrons. Electrons are tiny parts of an atom with a negative charge. Atoms also have particles with a positive charge. But remember, we said that electrons are the ones that move. Electrons move through a path called a circuit. So when the circuit is complete or closed, the electrons keep moving and the electricity flows. So you can see the difference between a closed circuit. You notice the bulb is lit. And an open circuit, so that means this part is open. They're not all connected. So the bulb is not lit. Or the electricity shuts off. Some electricity also comes from batteries. Now, small batteries like those in flashlights, these are called dry cells. However, most of the electricity we use is produced by generators. That's because we need a lot. So each year as the world needs more electricity, more generators are built to meet the demand. So you see the difference between using using batteries for your flashlight, and then you have a generator, then you have the power lines, and you can light up the city. Here are some common electrical symbols. You do not have to memorize these. It just shows you, for example, wire is, the symbol is just a line, and that means that it allows current to travel. Switch, that's a symbol for switch, that allows circuits to be opened or closed. So in this case, that switch is open. That means the circuit is open, so the electricity is not flowing, or electrons are not flowing. Bulb or light, there's the symbol. Motor, this one's easy, it just says am. Okay, and so on. So you have the same or similar pictures that's on page 11. It shows inductor, resistor, voltmeter, ampermeter, and so on. Again, you don't have to memorize those. It's for your information. So a dry cell, that's on page 11. So a dry cell converts chemical energy into electrical energy. So they come in different sizes and power levels. At home, when you're turning on the TV, that's very simple. You just plug the cord into a power outlet and you turn it on. So the electric current needed to power the TV comes from the outlets in your home. So what do you do when you're camping? So when you're away from home, there might not be any electrical outlets nearby, so you can power your devices like radio or flashlight. You will need dry cells and batteries, because these store electrical energy so that you can take electricity wherever you go. So despite their name, dry cells aren't completely dry. The outer part of a dry cell is made of zinc, which is a type of metal. Now inside there's a paste made of chemicals. So these chemicals will react with the zinc, causing it to lose electrons. This reaction creates a flow of electrons, which produces an electric current. So this process converts chemical energy into electrical energy. Here's the parts of a dry cell. A dry cell has two terminals. So one is positive, so this is the positive terminal, and then you have a negative terminal. So you can connect a wire between these terminals to create a circuit by adding something that uses electricity, like a light bulb, to the circuit. The electric current will flow through it and make the bulb light up. So there you have, again, a closed circuit, and then you have one that has an open circuit. The open circuit just shows that there's a gap that stops the flow of electric current. And then the closed circuit, it shows you that all the parts are connected. So now you have the bulb lighting up. Okay, a battery is made up of two or more dry cells that's working together. It provides more voltage than a single dry cell. The more cells a battery has, the higher the voltage it can produce. So you have two dry cells, okay, to power up a flashlight. Batteries are commonly used also in cars. So while the engine powers the car, the battery will supply the electrical current needed to start the engine. For example, this morning it was cold, maybe your vehicle won't start. That's because maybe the battery is dead, okay, or low. So it wasn't strong enough to power the engine. Okay, let's see if we can do some of the key questions. No, not yet. We still have to go through some of these terms. Okay, current electricity. So when electrons leave their atoms, they make matter electrically charged. So in static electricity, the charged particles move in all directions, while in current electricity, the charged particles move in the same directions. Okay, so that's how that's different. So static, the particles move in all directions, but in current, the particles move in the same direction. So most of the electricity that we use every day is current electricity. It's created by a generator, which collects electrons and pushes them all in one direction. This process forces the electrons to travel through a conductor. So we already talked about conductor earlier, which is a substance or material that allows electrons to move through it easily. Metal wires are the most common conductors that's used to carry it. And then the opposite are insulators, which is a material that makes it hard for electrons to move through it. And we said rubber is a good insulator. So you notice there's your wire, which is a conductor, and then there's your rubber part, that's your insulator. So if you were to touch that wire without the insulator, then you will probably get a shock. That's why you see electric wires are often covered with rubber to keep the electrons flowing inside the wire also. Types of current electricity, there are two types. One is direct current, or DC, and it occurs when the electrons flow in one direction all the time, just like the electricity from a battery. So this is the type of electricity used in most electronics we have today. So current is only flowing in one direction, not both. Some examples: batteries, like those in flashlights, remote controls or toys, cell phones, which use a battery to power the device. Same thing with laptops. They run on DC power from their batteries or charges. Electric vehicles, electric cars or scooters, they're powered by DC batteries. Solar panels, LED lights, so many LED lights operate on DC power. Portable power banks, these are used to charge other devices like phones or tablets. So these devices either use batteries or have components that convert alternating current or AC from an outlet to DC for proper functioning. Okay, just like your laptop. Types of current electricity, continuing with alternating current. This happens when the direction of the electron flow changes back and forth. So the electricity in the outlets at your house is alternating current. So household appliances, refrigerators, washing machines, air conditioners, televisions, these are powered by AC electricity from outlets. Microwaves, electric ovens, hair dryers, these commonly use AC electricity to operate the heating elements. Clocks, so if it's not battery powered, maybe you have ones that's plugged in, so the electric clocks. Electric fans, again, these are powered by alternating current to blow air. So most, if not all, home appliances are typically plugged into outlets where they receive alternating electricity to function. So let's look at key question 67. So this one, you have to match the electrical terms to the corresponding description. So in this case, we looked at, I'm going to circle the ones that we looked at already. Alternating current, we just did. Dry cell, insulator, conductor, battery, and electric current. Okay, so those you can look for their matching description. So let me do a couple here for you. So electric current, look at the description on the right hand side of that chart. So electric current is number, so this is number 2 on the left hand side, and it is matched with I, the flow of electricity from positive to negative through a circuit. Okay, this is electric current. So 2 is I. Battery, number 4 is B. So put number 4. A battery is 2 or more dry cells working together. Number 6, conductor. We know that's matter where electrons can move through easily, so that's A. So 6 is A. And we said battery was B. Insulator, matter that electrons cannot move through easily. Okay, so that's F. Okay, and so on. So you can try and finish that yourself. All right, so we did key question 69 and 67 today, and we'll finish up 67 on Wednesday. All right, that's it for now. I will talk to you again on Wednesday. Miigwech.